Most metals expand when heated. The Eiffel Tower, for example, can grow 10 to 15 centimeters taller in the summer due to thermal expansion. While this effect is common, it's a major issue in fields like aerospace, precision engineering, and electronics, where even tiny changes in size can cause big problems. That's why scientists have long searched for materials that maintain a stable size, no matter the temperature. One of the best known materials with this property is Invar, an iron-nickel alloy with extremely low thermal expansion. But for a long time, researchers didn't fully understand why Invar behaves this way. Now, a team from Vienna University of Technology and the University of Science and Technology Beijing have cracked the mystery, and in the process, they've created an even better material, a new alloy that barely expands across a massive temperature range. To understand how this works, let's look at why metals expand in the first place. When a material heats up, its atoms move more and need extra space, increasing the average distance between them. That's the basis of thermal expansion. Normally, this process is unavoidable, but in some special materials, it can be counteracted by another effect. Using advanced computer simulations, the TUYN team found that in materials like Invar, certain electrons shift to different states as the temperature rises. This weakens the material's magnetic order, causing it to slightly contract. That contraction almost perfectly cancels out normal thermal expansion, keeping the material's size nearly unchanged. While scientists already knew magnetism played a role in Invar's behavior, these new simulations provided the first detailed understanding of the process. So precise that researchers can now predict which other materials might have similar properties. To put this knowledge to the test, the team in Beijing created a brand new alloy called a pyrochloromagnet. Unlike traditional Invar, which is made of just two metals, this new material combines four: zirconium, niobium, iron, and cobalt. The result is an alloy with an even lower thermal expansion coefficient than Invar, and it stays stable over a much wider temperature range, more than 400 Kelvin. What makes this material so special is its internal structure. Unlike most crystalline solids, where atoms form a perfectly repeating pattern, the pyrochloromagnet has a slightly disordered structure. Some areas contain a bit more cobalt, others a bit less. These variations cause different parts of the material to respond slightly differently to temperature changes, balancing each other out so that the overall expansion is almost zero. This discovery could be a game changer for industries that deal with extreme temperature shifts or require extreme precision. Spacecraft, satellites, and high-precision measurement instruments could all benefit from materials that don't change size with temperature. By understanding the atomic level details of thermal expansion, scientists have not only solved a long-standing mystery, but also paved the way for a more stable, high-performance materials in the future. That's it for today, and thank you for watching. And as always, have a Voltastik day.